Good morning or afternoon. So this is a quick video about how to use the game involving the multicolored counters. If you have not been sent these, then this video is probably not the right space for you. The idea of the activity, which I'm going to call Throwdown, is it helps students build up a visual map of what numbers look like represented. It's called subatising is the sort of technical word for it. And I'm going to just pull this down so you get a see. You can look down there on here. So the idea is that the first way you can play this game is that you have a set number that everyone's aware of. I'd say 6 is probably the smallest. 7 is a good number to do as well, because 7's sort of students can do 6 quite well because they see it on dice a lot. 7's slightly harder. So actually, I'll use 7. And the idea is you just mix them up in your hand, you drop them on the table, and the student's job is to say what they see, why it makes 7, and justify it using some attribute on the table. So we could say here there are 6 red and 1 yellow. So we could split them by color. We could say it's by space. So I can see there's 3, 3, and 1. So it could be to do with their distribution. And what we don't really want more than 3 groups. So 3, 3, 1's good. I mean, you could say 3, 2, 1, 1, but starting to get broken up. Really, if it can be done in just 2 groups, that's best. So that's 6 and 1 makes 7. I'll just do another demonstration with 7. And so they dropped on the table there, and straight away the student could say, I see 5 and 2, 5 yellow, 2 red. Equally, they might say, actually, I see 4 and 3, because those 4 are sort of connected, and these 3 over here. It doesn't really matter what they say, as long as the combination that they've said makes the number 7. The next step after this, I would say, is, after having done maybe a minute of that, or done 10 of those, is to maybe change the number, include an extra one. So you've got 8, and identifying them from that. Or the other option is to, once students are getting better and better at it, is to not say how many. So you're keeping the number disclosed and then saying how many. And in this way, the students will have to internally, in their mind, see these as 3 and 2. So instead of saying, oh, I see 3 and 2, they'll say 5, but then justifying, well, I know it was 5 because it was 3 and 2. What was the quickest way? Oh, well, I saw these were 4 and they were 1. And we're building on the students' understanding already of subatising. They see this, they know it's 4, and then they combine that with another set. If I was to do that, they know there's 4, they see there's 3, and that they can instantly then combine these. And students will become quicker and quicker at then being able to, even if these were all the same and laid out in a particular way, more quickly recognizing those numbers. And being able to break these numbers into their parts is really crucial for what we're trying to do at maths and just general problem solving at this level. So I hope that was clarifying. Feel free to have fun with it or do something different, change it as you see fit. The idea, just keeping in mind, is that it's building up that bank of visual representation, seeing those numbers in our mind's eye and being able to see them as they come out so that we can very quickly identify those numbers. Thank you.